Hey, it's Lucky. This is part 2 of the Ultimate FPS Controller tutorial series. Be sure to check out part 1, it's the first link in the description to get to the starting point that we're at here. In this tutorial we're gonna be adding free looking, sliding, head bobbing and some procedural animation. Let's get into it. Alright, let's first check out where we left off in part 1. We created a basic controller, so we can walk around and look around. We can sprint, and we can crouch under objects, and stand up again, of course, and we can jump. In this tutorial we're gonna add free looking, meaning that you can walk in one direction while looking in another direction. We're gonna add sliding, so when you sprint and you crouch, do a little slide. And we're gonna add head bobbing, meaning the camera will bob up and down when walking to add a little bit of realism. So let's get into it. First thing we're gonna do, just like last tutorial, is set up some inputs. So we'll go back to project settings, input map, and we'll add a button for free look. Sliding will be a combination of sprinting and crouching, so we don't need a button for that. So we'll just add free look, click the little plus, and press the Alt key, which will be our key for free looking. Of course you can set these input maps as you please. Let's close this out, and let's set up some variables first. We're gonna want to keep track of the state of the player, meaning if it's crouching or walking or sliding or free looking. So we're gonna set up some booleans. In our variables, under the speed variables, we're gonna add another label. We're gonna call this one states. And in here we're gonna define all our states. So the first one will be walking, and it's false by default. The second one will be sprinting, and it's false by default. Crouching will be false, free looking, and sliding. Now we're going to want to set these variables to true when the player is in a certain state. So I'm actually going to copy all these variables and I'm going to set these where they need to be set. We already created this state machine in the first tutorial, right here. So we can already set a couple of these states. For example, when we're crouching, go all the way down. We'll paste all these states, remove the vars. And when we're crouching, we're not going to be walking, so that's going to be false, correct? We're not going to be sprinting, it's going to be false. We are going to be crouching, that is true. We can be free looking when we're crouching, so we're just going to remove this because we're not sure what it is. And we could be sliding when we're crouching, so we'll also remove this. Now, we can copy these 3 lines and go into our standing state, right here, and we have our sprinting and our walking state. And I think you can guess what we're going to do here. We're going to set our state flags accordingly. Now we might not even use all these state flags in the project, but it's just very nice to have your player controller have these states. So even another object, for example an enemy or door or your stage, can just look at the player, see these variables and see what they're doing without sampling their movement speed or their height to check if they're crouching or not. So let's update these. When we're sprinting, we're not going to be walking, that's correct. We are going to be sprinting, and we're not going to be crouching, so that one can be false. And in walking, we are going to be walking. We're not sprinting, and we're not crouching. So when are we going to be free looking? Well, we're going to be free looking when we hold down the free look button. So we'll go under our state machine. Let's keep this one at the top because it's the bulk of our code. And underneath, we'll add a new comment by going hashtag, and we'll call this handle free looking. So when are we going to be free looking? If input.is action pressed, like this, free look. So when this action is pressed, free looking will be true. And under this we'll add else, free looking will be false. So how are we going to free look? We're going to want to rotate our camera without rotating the whole player, so we can look in one direction while walking in another. For this we could just rotate our head, but it's gonna act weird when we're rotating the x-axis and when we're rotating the y-axis of the head. It's just gonna misbehave. So instead we're gonna add another pivot to our player controller. So for this, we'll click on player, right click it, add child node, add another node 3D, and we'll call this neck. And on our neck is gonna be our head. So you can drag and drop your head onto the neck node. Now we are referencing the head node here by its path, and this path is no longer correct. You can see we're just sampling head, but if you look in the player, there's no head, there's only a neck and then a head. So in front of this we'll add neck/head. And now we'll run the project again, so it work just as well. Yep, beautiful. The only thing we're gonna edit now, and this is why I made a mistake in the last tutorial, is the neck is gonna be not on the world origin, which it is now. Let me show you. It's at 0.0. And then the head is within the neck up there, and that's not how your neck looks. Your neck is not on the ground. Because this would mean if we turn our neck, you can see the head goes all the way off to the side. It's not what we want. So instead we'll set the neck to our player height, which was 1.8, like you remember. And then we can set our head to 0, so it's just straight on the neck. And then we'll have to edit a little bit of code. This part right here, this is where I made the mistake in the last tutorial by setting it to 0. This is why. So we can just remove that 1.0 and just set this one here to 0.0 in the standing logic and in the crouching logic. And now if you see, just worked the same, nothing changed, only that neck is at the right location now. So let's rotate that neck when we're free looking. This is going to be done in the mouse looking function. So right here, before we rotate our player, we're actually going to check if we're free looking. So if the current state is free looking, we're going to be still rotating something, but we're going to be rotating our neck. And this is going to throw us an error. Neck is not defined, which is true, because we don't actually get the neck variable. And we're going to do this just like in the last tutorial by clicking the neck, holding down control, and dragging it into our code. Now you can see we have a neck variable assigned to neck, and right here the error is gone. Now while we're not free looking, we're just going to rotate the player like normal. Let's reload the code and let's look at how it works. Right now we can just walk around, look everywhere, but when we free look, you can see we can look off to the side and still move in one direction. It's used in a lot of first-person shooters to sprint in one direction and check for enemies on the left or the right. It's a fairly new feature, but I really like it in every game I see it, so that's why we're adding it today. You can only see one problem. When we let go of free look, we're still looking off to the side and the whole movement is weird, it's inverted. So we're gonna want to reset that neck when we're not free looking anymore. This is super easily done in a little function that we're gonna write. So we'll go all the way down here in handle free looking. When we're free looking, we want to do nothing, but when we're no longer free looking, we want to reset the rotation of that neck. So let's type neck.rotation.y equals 0.0. Now the neck is just going to snap back to its original place. Let's check it out. Look into the side and we let go. We're looking straight again. Now that doesn't feel very nice, right? It's just snapping back. It's very abrupt. So again, we're going to add a little lerp to this, just like we did with a lot of variables in the last tutorial. By lerping this variable back to 0 instead of being instant, it gives a nice little smooth animation. Looks a lot better. So just like last time, in front of 0 we'll type lerp, and the variable we want to lerp, so that's going to be rotation.y. We're going to want to lerp it to 0. We're going to lerp it by delta times lerp speed, the variable we set in the first tutorial. Let's look at it now. As you can see, we can free look around, and when we let it go, it snaps right back to the right orientation. Looks very good. There's only one more bug we're going to have to iron out, which is we can free look all the way around, which looks a little weird. Your neck cannot do that. So as you might remember from last tutorial, we also clamped our head rotation, so we cannot look all the way up or all the way down. We're going to do exactly the same for the neck rotation. So we're just going to copy this line, go into the free looking mouse input, and we're going to go neck.rotation.y. So just edit these variables, copy this one, and then we're going to clamp the neck rotation, so right there. And I'm going to set it a little bit lower. Maybe we'll be able to look 60 to the left and 60 to the right. Let's check it out. Okay, so that's not enough. We want to look a little further. I'm actually going to go 120 and 120. Yeah, that looks a lot better. It's like looking over your shoulder. You can actually do it in real life. See how far you can look over your shoulder. That should be the angle of your free look. Now, a common thing that's also done in video games when free looking is tilting the camera a little bit. Because if you move your head over your shoulder, you're actually angling it a little bit, which adds a nice layer of realism. We're going to add this as well. For this, we're going to create a new variable. We're going to put it in movement vars. Movement vars is not really the right name because there's a lot of random stuff in here, but we'll rename it later. We'll say var free look tilt amount. We're going to set it to something small, 0.3. And now we're going to angle our camera by this amount. So we go down into our free looking logic, and while we're free looking, we're going to set our camera's rotation. So first we'll need our camera variable, which we're going to do again by clicking the camera, dragging it into the code while holding down Control and letting go. There's our camera. Let's copy this, go back into our free looking logic right here, and we'll say camera.rotation.z, which is the rotation of the camera from side to side. Oh, my bad. Rotation.z is equal to the neck rotation.z, because we're going to want to angle it based on how much we're looking to the left and the right, which is the neck rotation. .y actually, because that's the rotation of the neck. We're going to go to times free look tilt amount, and we're going to set this in degrees. Right now it's in radians, just like all our other angles we worked with. We want to set it to degrees with this little conversion function. So I'll just quickly copy that and put it right in front here. Let's see what it looks like. It might be too small. Not sure why it isn't working. Let me just set it to 1 for now. Oh, that's more sense. It should be quite intense actually. Oh yeah, it is working. It's just very small. Let's set it to something bigger. Free look tilt amount, set it to 10. Yeah, right now it's working. But it's inverted. We want it to look the other way, is that right? Yeah, I think so. So let's flip it around real quick. Yeah, that's how your head tilts when you're looking over your shoulder. Now it's a little bit much, so we're going to set it a little lower. Set it down to 8. Let's run it again. Yeah, that looks really good. That's like looking over your shoulder in real life. Now, one bug you're going to encounter is this. Your head stays crooked after you've free looked, which is quite funny, but it's not what we want. So, just like our neck rotation, we're going to reset our camera rotation when we're not free looking right here. You can see we're resetting our neck rotation. Let's also reset that head rotation. Just going to use the exact same lerp function. But instead of neck rotation, we're going to do camera rotation. All right, beautiful. That's free looking done. Now we can run around, run away from some enemies, check over our shoulder. Oh, there's nobody coming. It's a nice feature. I really like it. It feels really premium. All right. Let's move on to sliding and head bobbing. Alright, let's move on to sliding. The first thing we're going to do is detecting the start of a slide and the end of a slide. This is going to be done with a timer. So we'll create a sliding timer. Under our states vars, we'll create a new label and say slide vars. And in here we're going to create this timer. So var slide timer equals 0, 0. And var slide timer max, this will be the maximum of the timer, which will be 1. This is in seconds, so our slide will be 1 second. Now let's detect the start of a slide. You're going to want to slide when you're sprinting and you're pressing crouch. So in our state machine, we have these states for sprinting and for crouching. And we can actually detect when we're going into the crouch state if our last state was sprinting, just by adding our logic above the state setting. So in here, so we're pressing crouch, and if we are currently sprinting, then we're going to be sliding. So we'll set our sliding state equal to true, and we'll start up the timer by saying slide timer equals slide timer.max. And now there's one more condition we have to satisfy for a slide, and that's an input direction. Because if you're just standing still, you're holding down sprint and then you're pressing crouch, you shouldn't start sliding. You have to actually be moving. Now we already have a variable for our input, which is right over here, input dir. So if this is not 0, we're going to be sliding. Now there's one problem. You can see the vars being declared here, which means the code over here doesn't know it exists. So we just move this one up to the top of the code, cutting it out with Ctrl X, all the way at the top of the code, Ctrl V, add a little label, say getting movement input. So then we're just going to check here if we're crouching and sprinting, and by adding 2 and signs, input dir is not equal, exclamation point equal to vector2.0. So right now we're saying if we're sprinting and we're pressing crouch and our input is not equal to 0, we'll slide. Now let's handle this timer. So I'll go below free looking logic or sliding logic here. So handle sliding. And here we're going to say if we're currently sliding, then count down that slide timer. Minus equal delta, which is our time indication. And then if our slide timer is less than or equal to 0, our slide is finished. So we can say sliding equals false. So here we detected the start of a slide, and here we detected the end of a slide. Let's add some print statements here just to test it. So we'll add print slide begin. I'll copy that line, and then here we'll say print slide end. And then when we run the project, we're not going to be sliding, but you'll see the timer running. So we'll sprint and we'll press crouch. You can see down below in the console, slide begin, slide end. So now let's actually make a slide. So there's a couple of attributes to a slide, the direction and its current speed. And we're gonna want to take away control from the player, so you cannot move around with WASD, but instead move in the slide direction. So first let's create a variable for this slide direction. In the slide vars at the top, we'll say slide vector equals a vector2.0. And then let's capture this slide vector at the beginning of a slide. And of course we have our logic right here. We'll actually label it. We'll say slide begin logic. And in here we're going to set that slide vector equal to our current input vector. So we'll capture our current input and just repeat it for the whole slide. So keep moving in one direction. Then let's actually do that. So we'll say slide vector. It's going to be our input direction for the duration of the slide. So all the way below where we set our direction, we're going to overwrite this. So right here we're going to say if we're sliding, overwrite that direction variable, and we're going to override it with our transform basis, which means take into account the rotation of the player and then add to that our slide vector. Now this is going to be a vector tree, so we're going to need to convert it. So we'll say right before that slide vector tree, open up the brackets and say slide vector.x. There's no y because we're not sliding up in the air. And then slide vector.y is the last statement. Then we want to take this whole thing and normalize it. It's throwing me an error right now. Oh, it's basic. It should be basis. Just like we're doing up here, we're normalizing it. We're also going to normalize it here. This means that the direction variable will be between 1 and 0. Normalized. Now we have another problem. You can see when the direction is applied to the player, it's applied with the current speed, which is our walking speed or our running speed or our crouching speed. But we want a custom speed for the slide. We want it to start off very fast and end really slow. So we'll also override this velocity variable. We'll go below the declaration and say if we're sliding, we're going to be doing something else. It is, however, going to be very similar. So I'll just copy this over and drop it in here. And it's not going to be our current speed, but it's actually going to be that slide timer. Because at the beginning of the slide, the timer is going to be 1, so it's going to be very fast. And at the end, it's going to be 0, so it's going to be very slow. Now there's one more thing that's going to be wrong with this, and that's our mouse can rotate the player. When we move left to right with the mouse, our players can look left and right, so we can curve our slides, which is not what we want. We want it to be a nice straight slide. And we actually already created some logic for this, our free looking logic. So we'll just free look when the player is sliding, and when it's not sliding, we'll stop free looking. So in the slide begin, we'll set free look equal to true. And in the slide end, we'll set free look equal to false. And then in the free looking logic, we're actually setting it to false all the time while we're not holding down the free look button. So we're going to say, if we're free looking, we want to free look. And if we're not, and if we're sliding, we're going to be free looking. So go NN sliding. So let's test this out. We'll take a sprint and press crouch. You can see this very slow and short slide. So let's actually add some speed to the slide. So we'll go all the way up to the top to our slide variables, and we'll set for slide speed, set it equal to 10, something big for now. And we're going to multiply, so I'll just copy this variable slide speed, and then down where we're setting our slide speed in the sliding logic here, all the way at the bottom of the function, we'll multiply that time slide timer with our slide speed. Let's run it again. It looks more like a slide. You see? Our free looking is not working. Let's debug that. Oh, it says NN. It should be or. So if we're free looking or we're sliding, which is done with this, these two characters, these standing line characters, to right above your enter key. So if we're free looking or we're sliding, we should be free looking. So now we're just sliding on our feet. We're not actually crouching for the slide, which we want. So we'll go into the crouching logic and make sure that we also crouch when we're sliding. So right here we can see if input is pressed crouch, we'll just add the same logic, or we're currently sliding, we're going to be on the ground and sliding. Let's test it again. Sprinting and press slide. Now you can see that beautiful slide. We can slide under something and then continue walking here because we got this detection. Now one thing I did to make this a little more nice is I add a little bit to the slide timer when we're generating the speed. Because right now you can see we're starting at 0. And I really like it when the slide has a little bit of momentum at the end, so you can slide and keep moving. It's personal preference, but I'll show you how to add it. It's very simple. You just go down below where we're generating that slide speed. And right here I'm gonna set the slide timer in these brackets and then add 0.1. So it never truly reaches 0 in the speed. You can see it ends with a little bit of speed, so you can slide and keep moving. Now one thing I'd like to do is a slide cancel, meaning that if you're sliding and you want to stop, you can press jump and it will get out of the slide, which is very easy. So let's also add this here. You can see handle jump, so when we're jumping, we're going to set sliding equal to false. So we'll just end that slide right there. You can see, so when you're sliding into something you don't want, you can do a little E. And it's also fun because you add slide jumping, which means if you slide and jump, you get a little bit more momentum. So that's sliding almost done. There's one more quality feature I'd like to add, and that's when you slide, you tilt your head to the side a little bit. And as you know, we already have some functionality for this in free look, right there. So we just go into our free looking logic, where we're rotating our head, right there. So in here we'll just detect if we're sliding, and then we're gonna want to rotate this camera Z, which we're already doing here. So we'll actually say if we're not sliding, then we rotate this camera with the tilt amount. But if we are sliding, we have our own little slide tilt, which is gonna be, just remove this, and I'm gonna say 7. Let's try that out. So what this does is it goes into the free looking logic, and if it's a slide free look, we'll have a little tilt for sliding, and if it's a normal free look, we have the over the shoulder tilt. Okay, so it's a bit aggressive. So we'll actually lerp this, just to add a little bit of smoothness. So we'll lerp camera rotation.z, and we'll lerp that to -7 degrees. And of course we'll lerp it by the delta times the lerp speed. Run it again. Yeah, it looks pretty good. You can slide around. You can of course play with the slide speed, slide timing to get the perfect slide for your game. But I really like this. You can slide under this wall, crouch under it. Alright, perfect, that's sliding done. Last thing in this tutorial, head bobbing. So, let's move on to head bobbing. Head bobbing is actually quite easy. We're just gonna have to set up a bunch of vars. So I'm gonna create a new label underneath my sliding vars and say head bobbing vars. Because the way that we're gonna implement head bobbing is we're gonna generate them in code, the animation, and we're gonna do it with 2 sine functions. If you know, a sine function is this wave function, and we're gonna combine 2 to have a side to side and an up and down to create this step effect. And then we're gonna tweak the speed and the intensity of this effect based on if we're walking, sprinting, or crouching. But we need all the variables, all the speeds and intensities. So we're just gonna set them up right now. I'm gonna copy these values from my demo example because I already tweaked them and they work nice for me. Of course you can tweak them how you please, but this is what I used, so we're going to use it right here. So the first thing we're going to set up is the speeds. We'll create 3 consts, and we'll call them head bobbing, sprinting, speed, and this one is going to be equal to 22. Then we're going to create our head bobbing walking speed, which is going to be equal to 14. Then we're going to create our head bobbing crouching speed, which will be 10. And then we're going to create 3 more variables for intensity. So the speed will be how fast we move side to side and up and down, and the intensity will be how much. So let's create 3 more variables. Crouching intensity. And our crouching will be 0.05. These are in meters, so they're going to be quite small. You don't want your head to go 1 meter to side. Let's copy this line actually and just paste it 2 more times. Then we can just copy sprinting, move to the top one, and walking. And the second one, our sprinting is going to be 0.2, it's 20 centimeters. Sounds like a lot, but it's quite realistic, I find. And our walking is going to be 10. Now we're going to need a couple of variables to keep track of where we are in the sine function, so our index in the sine function, and to keep track of the up and down of our actual head bob. So for this up and down, we'll create a variable head bobbing vector, which will be a vector.0. So a vector has an x value and a y value, so we'll keep track of our side to side and our up and down. And then we're going to create a head bobbing index, which will be 0.0. This is how far along the sine function we are. If you know a sine function, you plug in a value, and this is going to give you this wave when you increment it, and that's the index value, the value we plug in the sine function. And we'll add our speed to the index according to if we're sprinting, walking, or crouching. So that will determine the speed of the wave, aka the speed of the head bob. So let's set up that logic now. Go down into our physics process, and we'll create under slide, create a new label. We'll call it handle head bob. And let's first detect all our states, so we can set the speed and intensity accordingly. Start with sprinting. If we're currently sprinting, then our head bobbing intensity wait, did I create this variable? Yeah, right. Oh no, sorry. I forgot one less variable. It's our current intensity, because we're going to swap this out based on our state. So let's create one more var. Head bobbing current intensity equals 0.0. And this one is going to be changed to the intensity that's appropriate for the situation. So for sprinting, our current head bobbing intensity will be our head bobbing sprinting intensity, elif, which means else if we're walking. So if we're walking, our intensity will be our walking intensity. I think you can guess what we're doing next. I'm going to check one more time for our crouching state. And if we are crouching, we're going to use our crouching intensity. Perfect. Now, like I explained, we're going to use a sine function with this index, our head bobbing index. And we're going to add our speed to the index to determine the speed of the head bob. So that's what we're going to do next. Let's grab this index. Go back down to our logic, and for sprinting we're going to add that sprinting speed. So head bobbing index plus equals head bobbing sprinting speed. And now because this is a time variable, we're going to need to use that delta, that time indication. So let's multiply this by delta. Otherwise we're gonna have it tied to the frame rate, which we don't want. Let's copy this line, paste it into walking and paste it into crouching, and update these variables. This one's gonna be our walking speed. Oop. And this one is gonna be our crouching speed. Now you could optimize this piece of code by writing a library with all the values and then just sampling this library based on the state. But this is just more readable, and I don't think there's going to be a lot more states. So for this example, it's fine, I think. Now let's actually apply this head bob. For this, we're going to need to check if we can currently head bob, because for example, if you're sliding or if you're in mid-air or if you're not walking, you don't want to head bob. So let's write a function for that, or a condition. So first of all, we have to be on the ground, which we'll say is on floor. We use this is on floor function. And we're also not sliding, because if we are sliding, you don't want to head bob. And our input direction is not equal to 0. It's not equal to vector.0. So this basically says we are on the floor, we're not sliding, and we are currently walking. That's when we want to head bob. So let's generate this sine function. It's actually very easy. All you just do is you grab your head bobbing vector, and we'll start with the y. And we'll just set it equal to a sine function with index, head bobbing index. And that's it for the y. And then we'll also do this for the x. But this one is going to be modified slightly. We're actually going to divide it by 2, our index within the sine function, and we're going to add 0.5. This is so for every side-to-side movement, we go up and down twice. And we're going to offset it by 0.5 just to get the timing right of the sine functions. Alright, so now let's apply this sine function to our actual camera. For this, we're going to create another pivot. Just like for the free look, we created this neck pivot. For the head bob, we're going to create another pivot. We're going to do it under head. So right click your head, add child node, node 3D. And we'll call this eyes. Of course, your eyes in real life are not the part that's doing the head bobbing, but for naming's sake, we'll do it like this. So your neck as your head as your eyes, and your eyes as the camera. Let's go all the way to the top of our code to update these variables. You can see our camera is still referencing neck head camera, which is no longer true because we put those eyes in the middle. Then we also gonna want that eye variable. So grab your eye node, hold down Control, and drag and drop it in. So now we can move these eyes with the head bob. So grab this variable, Control C, move all the way down to head bobbing logic, and then let's head bob these eyes. So eyes.position.y is going to be equal to a lerp function. We are going to lerp this, otherwise the start and the end of the head bob are going to be very jumpy, which we don't want. So lerp, what we're going to lerp, our eyes.position.y, where we're going to lerp it to, our head bobbing vector .y. And now this is where our intensity comes into play. Remember, we're setting these intensity variables. This is how much we're going to move them. And we're working with the position now, so this is where we're going to apply it. So for the y, we're going to multiply this by, open up some brackets, head bobbing intensity. Current head bobbing intensity. And we're going to divide this by 2. Because if you look at the head bob, you can see it goes more side to side than up and down. So you want it a little lower. Of course you can tweak this if your game has a more intense head bob, like more up and down than side to side. This is the variable you want to tweak. But for a normal head bob, it's a little more side to side movement, a little less up and down. That's why we're dividing it by 2 right here. And the last value we're going to need, I think you can guess it, it's going to be delta times that lerp speed to get that time indication. Let's copy this line, paste it below, change all the y's for x's, and remove that divided by 2. You can actually remove the whole brackets. Because it's relative to this, of course, so if we're going to divide this by 2 as well, then it's still going to be square. We want that nice flat side-to-side head bobbing motion. The last thing we're going to do for head bobbing is resetting our eyes when we're not head bobbing. So right here we have all these conditions for head bobbing. And I'm going to plug an else at the end. So this is if we're not head bobbing. We're just going to reset those eyes to 0.0. So we just copy these lerp functions. And instead of that head vector, we're just going to say move our eyes to 0.0 because we're not head bobbing at the moment. So we wrote a bunch of code and we're going to run it all at once now. Let's hope it works first try. There may need to be some tweaking. Let's see. Okay, there's going to be needing some tweaking. You can see our head bobbing is going in this weird diagonal. Let's see for the sprinting. Yeah, for the sprinting as well. Let me quickly troubleshoot this and then I'll get back to you. Ah, yeah, here it is. X. This one also needs to be an X, of course. And right here you can see I also made a mistake. In the second line we're doing the X and I forgot to change an Y to an X here. And I did the same here. Make sure when you're using the X vector, you're also using the X vector in the lerp. And here also. You guys probably didn't make that mistake, it was just me, but yeah, that was what was wrong. And there you go. This is I'm walking up to a wall right now, so you can easily see the animation. This is the walking. That's the sprinting. And then here is the crouching. So very slow side to side. And this is what it looks like in motion. And then when we slide, it stops and then continues when you run again. I really like that, it's really snappy. Looks really good. Alright, so that's our second tutorial done. We added free looking, so we can look over our shoulder. We added sliding, and we added this awesome head bob, which is all procedural. Alright, part 3 is going to be all about your guys' requests. I got a lot of requests last time in the comments, and please drop some more requests in this one so I can add some more features in the third one. Maybe we'll even create a fourth tutorial with more user requests. But in the first one we're also going to add air control. So right now if you jump and you let go of your movement, you just stop mid-air. And in the next one we're going to add so you can keep some momentum and you can tweak the amount of momentum you're keeping. We're going to add some more nice things. We're also going to add keyframe animation. So right now all our animation is procedural. For example, if you want a hit effect or a roll, like I show in the demo, you're going to need to keyframe some animation. And yeah, drop any requests you want in the comments. I'll try and get to all of them. So until the next tutorial, bye.